Okay, so here's part two. We're just continuing along through all these problems. So, in this diagram, STU is an isosceles triangle where ST is congruent to UT. The paragraph proof shows that angle S is congruent to angle U. What step is missing in the proof? So really, you're proving two pieces of a triangle are congruent. Typically, that's going to be CBTC, so let's look. So it's given that this congruent to that, draw this and that, yada yada yada. Really, what you can do is kind of look at, all right, S is congruent to U. What happened before it? It said TV is congruent to TV. So basically, in this, they created these two little triangles, and they said, okay, well, uh, STV, this angle is congruent to that angle. Then you get reflexive. And so then they did side angle side, right here. And they said, all right, then if you know that this little triangle is congruent to that little triangle, S is congruent to U. So that would be the corresponding parts of congruent triangles are congruent. Not too much of that one. You just have to remember what CPCTC is. And then you could also do elimination, like S and U aren't reflexive. They're not the definition of right angles. And angle congruence postulate, that doesn't make sense. So these, you may just want to look real quick over like Google. I'm going to tell you what they are. Like this one is it is an angle bisector. This is what they look like. So you went from this to this. That's pretty much it. This is a perpendicular bisector. Right here. You went from AB and you made this perpendicular bisector. 3, this is perpendicular to a point. Oh, sorry, my screen came off. Hang on. Sorry about that. Perpendicular to a point. Okay. Sorry, my brightness is weird now. Hang on. There we go. Okay. Now it's too bright. Okay, whatever. So if this is perpendicular to a point, it just had this point outside of L and became perpendicular to it. This is you started here and went here, and to me that looks like you made parallel lines. O is you made an or 5 is you started with center O and made this equilateral triangle. Okay, I know my handwriting's terrible. I'm trying to get through it, through some of the simple stuff without being super nice. 6 is you started with a circle, and then inside you did these two, bisectors, and you made a square, inscribed square. 9 is you made an inscribed hexagon. So what they're going to be asking is, what step might be next, or what does this completed or part of this proof look like? These are all the proofs that you have to know. So if you really want to go in and figure out what all the steps are, then you can do that. But that's pretty much it. And you can just go through each one. All right, so moving on. Okay. So, using coordinates to prove simple geometric theorems algebraically. Which information is needed to show that a parallelogram is a rectangle, that the diagonals bisect each other? That is a fact that you have to know. But that might be, let's see, it could be other things. The diagonals are congruent. So basically, if you had a rectangle, you're talking about diagonals. Because some parallelograms, their diagonals bisect each other anyway. So like, a square, for instance, or a, like, these could bisect each other even if they're slanting. So it's not necessarily A, the diagonals are congruent is true. The diagonals are congruent and perpendicular. Like, that's not true. The diagonals bisect each other and are perpendicular. No, that's not true, because that could be, that's a rhombus. And then they bisect each other. That is true, but that doesn't prove that they are, it doesn't prove a rectangle, so it's B, that they're congruent. Because basically you could have a rhombus and you could have something like this. And yes, they bisect each other, but they are not congruent. In a rectangle, your diagonals are always congruent. So like that's always true there. So you need to prove that they're congruent. Look at the quadrilateral ABCD. Which information is needed to show that ABCD is a parallelogram? Let's see. Use the distance formula to show that the diagonals AC and BD have the same length. Not necessarily, because one could be longer than the other. So that's not needed. Let's see. Use the slope formula to show that segments AB and CD are parallel. And are perpendicular. Okay. And AD and BC are perpendicular. Well, they don't necessarily have to be, because that would only tell you a rectangle. They could still be a parallelogram without saying that they're perpendicular, so they don't have to have 90-degree angles. Use the slope formula to show that AB and CD have the same slope, and that AD and BC have the same slope. That would work, because then you'd be like, oh, those are parallel to each other, and these are parallel to each other. So opposite sides are parallel, and therefore it is a parallelogram. There are two pairs of opposite parallel sides, so don't worry about D. Like AB and AD have the same length, CD and BC have the same length. So there's not that, you don't even need that. That would be a square, but you can be a parallelogram without being a square. Consider the construction of the angle bisector below, which could have been the first step in creating this construction. And it's going to be, drawing arc AB would be first. Place the compass on point AB. Let's see, place it on Y and draw an arc that intersects YX and YZ. It's this one. You have to do your arc out from here first, and then do your arc out here from A, and then do your arc out here from B, and then you can do your bisector. And that's your angle bisector. But first you have to draw that first line. 4. Consider the beginning of the construction of the square in the circle below. Label point R on circle Q. Draw a diameter. Label the point where the diameter intersects point T. What's the next step? You need to draw now a perpendicular bisector of RT, so it would look something like this. Because when you do that, you have this line. All of these would be congruent, and then you could just connect and make a square. So if you did a perpendicular bisector, you'd have it like a line segment parallel to RT. That could be that. That doesn't work. Label point S on circle Q. You could do that anywhere. Like, say that's S. That doesn't help. Draw radius SQ. Again, I just did S. Like, that could be that. So you have no idea. You have to do the perpendicular bisector first. Moving along. In right triangle ABC, A and B, angle A and angle B are complementary angles. The value of cosine A is 5/13. What's the value of sine B? So basically, here's how this works. Draw a triangle. Call it, let's see if they want. Okay, so A, B, C. If cosine A is 5/13, that means that's the adjacent over the hypotenuse. So, cosine of A would be right here. The adjacent side would be 5. The hypotenuse would be 13. What is the value of sine of B? Sine of B would be right. B would be right here. That would be opposite over hypotenuse, which means you'd have 5 over 13, the opposite side over the hypotenuse. So it would be the same. And because they're complementary angles, this kind of tips it out. They would be the same also. So, like, remember the sine of 30 is the same as cosine of 60. Okay, so that's what it's saying about A and B. So these two, if they add up to 90, are the same. Another example would be like sine of, 70 would be the same as cosine of 20. So because it tells you that they're complementary, they are the same thing, basically. But if that doesn't, like, if you can't see that right off the bat, then I would draw a triangle. Since A and B are the angles, I would put A and B as not the right angle. I would do A, B, C, and then, all right, cosine of A adjacent for hypotenuse, 13 is my hypotenuse, and then my adjacent side would be 5, and so on and so forth. You can figure out B from there. All right, what is the value of cosine of A? That's adjacent over hypotenuse, so it would be 9 over 15, which is, reduces down to 3 over 5. So A. In right triangle HJK, let's see, J is the right angle. There's J. H, let's call it this, and K right here is right angle, and the tangent of H is 1. So basically, the opposite side and the adjacent side make 1 happen. Which statement in triangle which statement about triangle HJK must be true? Well, here's the cool thing. If you know it equals 1, then that means this over this, like it would have to be like 5 over 5, because 5 over 5 would give you 1. So let's see what it's going to say here. Which means that the hypotenuse here would be root 2. This is an isosceles triangle. So sine of H would be opposite over hypotenuse. It wouldn't be that, because 5 over 5 root 2 wouldn't be the case. Sine of H would not be 1, because, again, it would be weird. It would be C. The sine of H is the same as cosine of H, because these two angles are the same. Oh, sorry. Those two angles are the same. Like, the sine of H would be 5 over 5 root 2. The cosine of angle H would be also 5 over 5 root 2. So it would have to be C. 4. A 12-foot ladder is leaning against a building at a 75-degree angle with the ground. Which equation can be used to find how high the ladder reaches up to the side of the building? So here, know what angle you've got, know what side you got in relationship to that angle. This is the opposite side. This is the hypotenuse. If I did opposite and hypotenuse, that's sine. So it'll look something like this. Sine of 75 degrees equals x over 12. And that is, which one? D. Yep. All right, moving along. A hot air balloon is 1,200 feet above the ground. The angle of depression from the basket, the hot air balloon, to the base of the monument is 54. Let me go ahead and tell you, this angle and this angle are the same because they are alternate interior angles, because the ground is parallel with that line. Which equation can be used to find the distance d in feet from the basket of the hot air balloon to the base of the monument? So from the basket of the hot air balloon to the base of the monument, so from here to here, you want to find d. Okay. So again, think about what you have. You have this angle. Here you have, according to this angle, this is opposite of it. And then you have the hypotenuse here. Opposite and hypotenuse is sine. But the hypotenuse is going to be on the bottom, so you have sine of 54 equal to 1,200 over D, which is B. So be careful. One thing is know that the angle of depression there is going to be the same right here. Be aware of that. And you will have sine, cosine, and tangent given to you in your formula sheet, so you don't have to get those out of nowhere. All right, circles, volume. Understand and apply theorems about circles. Circle P is dilated, forms circle P prime. Which statement is always true? The radius of the circle P is equal to the radius of circle P prime? No, because one's bigger than the other. The length of any chord in circle P is greater than the length of any chord in circle P prime. That is not always the case, because you could have like that and like a little teeny tiny chord up here that could be smaller than that. The diameter of circle P is greater than the diameter of circle P prime. You have no idea, because you don't know which one's bigger or smaller, honestly. The ratio of the diameter to the circumference is the same for both circles. That is pi, so that is true. Like, if I have a circle, that diameter to the circumference going around it will always be 3.14, no matter how much bigger the circle is. Like, the diameter will always go around a circle 3.14 times, 3.14159, and so on times. So it's D. 2. In the circle shown below, BC is a diameter, and AB is 120. Okay, keywords here. BC is a diameter. That means you just cut that circle in half. So this is 180 degrees. What's the measure of ABC? And you want to find that. That is inscribed right there. Okay. So, we saw that, all right, got a diameter, 180 degrees. We've got 120. We're supposed to have 360 in a triangle. 120 and 180 is 300. So 360 minus 300 is 60. So an inscribed angle is always half, or the angle is always half of the arc, like the arc's always bigger, so B would have to be 30. We just do 60 divided by 2, and that's 30. Find the arc length. Arc length in the area of sectors. So circle E is shown. What is the length? That means we're using circumference. That's 2 pi r of CD. All right, so CD, you got the central angle 145. 145 out of 360 times 2 pi r. 2 pi radius is 12. So you get 145 over 360 times 24 pi. Let me punch that in my calculator. And you will wind up with C. Comes out to be 29 over 3 pi. Now, if you have trouble with your calculator, I would just convert this to, like, if you're only getting decimals, then just do this decimal, and then do that, like your decimals over here, and see which ones are the same. All right. Here we go. What is the area of the shaded part of the circle? So now, area, so you get pi r squared. I think on your formula sheet it looks like this. You really just plug it in. So pi radius is 9, but you have to do a little work here. Shaded part, all right, 75 is the non-shaded part. So to get the angle for the other part, you do 360 minus 75, which comes out to be 285. Yeah. And then so plug it in over 360. You type that in, and you wind up with D right here. Okay. The spokes of a bicycle wheel form 10 congruent central angles. The diameter of the wheel formed by the outer edge of the wheel is 18 inches. Okay, so this is 18. What is the length of the nearest tenth of an inch of the outer edge of the wheel between the two consecutive spokes? So you want to know how long this is. Like, how long is that part right there? All right. So if I know the whole length is 18, then I know that this is 9 because it cuts in half. There's 9. I want to know the length, so that's going to be 2 pi r. But I don't know my angle here. But if you think all the way back from part 1 in the review, if I have, I want to know my angle of rotation, I could do 360 divided by 10 and get 36. That means this angle right here is 36 degrees. Okay, so 2 pi r, 360 over 360. And we get really just 2 pi r, 2 pi times 9 over 36. And you can type this all on your calculator. You come out with, what is it? B. So, really the key there was knowing, hey, in order to get that angle, I need 36. The other key was realizing in order to find that length there, I've got to use 9 because 18 was my diameter. Explain volume formulas and use them to solve problems. Jason constructed 2 cylinders using solid metal washers. The cylinders have the same height, but one of the cylinders is slanted as shown. What's true about Jason's cylinders? They have different volumes. That is incorrect. They're the same washers. They have different volumes. Incorrect. Same washers, same height. They have the same volume because each of the washers has the same height. That's not true. They could be like skinnier. They could be smaller washers, and we know that they're the same. The cylinders have the same volume because the same cross-sectional area at every plane parallel, because they have the same cross-sectional area at every plane parallel to the bases. So basically, a stack of washers, a stack of CDs, a stack of paper, they all have the same area at every single point. So they're going to have the same volume if you stack them up and they have the same height. Now, if you added another washer, they wouldn't, because clearly this one on the left would have more. But if they are stacked the same and made of the same thing, essentially, they're going to be the same. That's that Cavalier's principle. What is the volume of the cylinder with a radius of 3 and a height of 9.5? Well, a cylinder is base times height, capital B, times height. The base of a cylinder is pi r squared times height. So pi, radius of 3, times, that should be a square. Radius is 3, a height of 9 over 2. You get pi times 9 times 9/2, which would be 81 over 2 pi. So you'd come out with A. All right, so I'm going to move on to the next part here and stop this one here.